Welcome back. This is Mr. Hassan's Maths channel, and I'm now going to be answering question number 13 from the specimen paper, paper 4, extended syllabus for the new 2025 specification from Cambridge IGCSE 0580. And this question here is about trigonometry, it seems. So we're given this question with this triangle and this second triangle, which are kind of like placed together with AC as a common side. Triangle ABC is a right angle triangle. Okay, so this quadrilateral is formed by these two triangles stuck together. So the first part of the question says, calculate the angle BAC. The angle BAC. So first of all, we should know how to identify the angle that they're asking us to find. That's something sometimes students don't understand that. So it's always the letter in the middle. That's the place where the angle is measured. And these two are the lines that lead to the angle. So you go BAC. So these two lines lead to the angle in the middle. So this is the angle we're trying to find. Let's call it theta. So let's just let angle BAC, let's call it theta. Okay. So now we have to find this angle. Well, this angle is part of this right angle triangle, as we can see. So when we see a right angle triangle, we can use SOHCAHTOA. I mean, we should know that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. SOHCAHTOA. That helps us to remember the ratios. So in this case, the right angle is over here, and the side opposite to the right angle is always the hypotenuse. So this would be the hypotenuse in this particular triangle ABC. The one that we're concentrating right now, the one that we're looking at this moment, is the triangle ABC. Okay, that's the triangle that we're concentrating on. So the side opposite the right angle here, that's the hypotenuse. And the other sides, well, they depend on which angle we're trying to consider. So we're considering this angle. We're trying to find this angle here, theta. So the side which is like directly across from that will be the opposite side, and the side which is next to that, which isn't the hypotenuse, would be the adjacent side. So in this case, we have to deal with the adjacent and the opposite side. Okay, and we can see that the tangent is the one that is the ratio that deals with opposite and adjacent. So what we can do is we can find this angle by using the tangent ratio. So the tangent of the angle theta will be equal to the ratio of the adjacent side, the opposite over adjacent. So the opposite side, which is 14, over the adjacent side, which is 12. It's opposite over adjacent, TOA. So tan theta equals 14 over 12. So we can now work out what the angle is. We can say theta is equal to inverse tan of 14 over 12. We could simplify that fraction, but there's no need to. We can just leave it as it is. So we take a calculator, we make sure that it's in degree mode. Okay, if you're not sure, you go to, oh no, you don't do this. Sorry. You press shift, and then you press this, so you get the menu. You go to angle unit, which is 2, and then you press 1, make sure that's in degree mode. Right, that's how this calculator works. Most of you will have the same calculator as this. There are other calculators which maybe you need to make sure you understand how to do it before your exam. So now, inverse tan. So shift tan. Now I'm going to put my fraction bar and I'll put 14 over 12. So this tells me the angle which has this as its tangent ratio. Press equals, and you get 49.3987. So that's 49.3987. Now, angles should always be rounded to the nearest degree. To one decimal place unless otherwise stated. Angles should always be rounded to one decimal place unless otherwise stated. So in this case, it's going to be 49.4 degrees. Okay, you got to be careful about this because sometimes your angle might come out in certain questions, like it might come out as, for example, 4.94 or for example, 124.56 or something like that. So if it comes out like this, you have to write it as 4.9 degrees, one decimal place. Like this, 124.6 degrees, one decimal place. Okay. not the same as length. For length, you would leave this as a 4.94. For length, you'd write this as 125. But for angles, you should have one decimal place. Other values will be given to 3SF. In this case, 3SF and one decimal place are the same thing anyway. But just be aware, if your angle is, one digit in terms of like it's less than 10 and it goes on, you have to only round to one decimal place. Okay, so be careful of that. In this case, it's just the same. Now, that's part A done. Now we're going to go on to part B, and I've got a diagram copied so that we can just refer to it. So we got to find the length BD. Now I've already drawn this on here, but the length BD would be the length between these two. Okay, so I've got to consider this triangle ABD. Okay, the triangle ABD. Okay, and I want to find this length here. Okay, I don't have any information about the angle on this, but I have information about angles on here. This angle here is what we just found. This part. We just found the angle BAC. Okay, that's what we just found as 49.4. Okay, rounded to one decimal place. So what I'm going to do now, I'm going to take this triangle, right? This triangle over here. Okay, I've just made a little kind of a sketch of it. Just say this is a sketch. It's not a very accurate sketch of it, but I made a little sketch of this triangle. Could have been more accurate. Anyway, just say that this is a triangle BAD. I'm just taking it out so we can see more clearly. So this is A, and this is D, and this is B. Now the angle BAD, or DAB, I'll call it, a bit more positive, DAB, is going to be 62 plus theta. Now theta is this angle. I'm going to write it to a higher degree of accuracy than required in the answer. Okay, because whenever you are using values from a previous part of the question in the next part of the question, always use the more accurate version of it. So that's why I've written this in its unrounded form and then rounded it for my final answer, because I can use this now in my next part of the question. So this angle is going to be 62 plus 49.3987. So we can take our calculator. Now the last answer we had was the exact answer for this. Okay, so we can add to it 62. And that gives us 111.398. Or let's like 111.397. 111.397. Or dot. Okay, so that is the angle. Okay, DAB. And we know this length is 15 centimeters. We know this length is 12 centimeters. We have these two lengths. So this is a classic case now of using what's called the cosine rule. When you have two sides and the angle between the two sides, you can find the third side using the cosine rule. And the formula for the cosine rule is actually given to us in the paper, although after a bit of practice, I'm sure you won't really need to refer to it. But if you look here, the cosine rule is given to us over here. This is the cosine rule. Okay, that is a cosine rule given to us in the paper itself. So we can use that. A squared equals B squared plus C squared minus 2BC cosine A. So for the cosine rule, the best thing for you to do is not to memorize it just purely. Of course, we don't need to memorize it now, but we need to know how to apply it. So what we'll notice is that these two will always be opposites. These two, A and the cosine A, the angle A and the side A, will always be opposites. Okay, so if you're trying to find this side, then you're going to have this squared plus that squared minus 2 times this times that times the cosine of this. But if you're trying to find this side, then these two sides will be your angles over your sides over there. And this will be the angle that you need. So this side squared equals this squared plus that squared minus 2 times this times that times the cosine of this. So it's always best to, rather than memorize the cosine rule, okay, and just like, well, you don't have to really memorize it anymore, but you should look at this and be able to know how to apply it. Okay, it's not just random lengths that you put here. So if we go back to our question, okay, which is over here, right, then we can see that this is the side that we're trying to find. So I'm going to call, well, I can just call it BD. So what I like to do, instead of putting squared, I like to write this as the square root of, so I won't forget to take the square root out at the end. So I'm going to have these two sides squared and added. So let's say this 15 squared plus 12 squared minus 2 times these two multiplied, 2 times 15 times 12 times the cosine of the angle between them, which is the angle opposite the side we're looking for, which is 111.3987 ... I've written down in this form. Now what I'm going to do is I'm going to take my calculator and I'm going to leave this answer as it is. Okay, this is now the answer in my calculator. I'm going to start typing this down. So square root of 15 squared plus 12 squared minus 2 times 15 times 12 times the cosine of, I'm going to put answer, because the last answer was this angle. All right, I'm going to press equals. We'll give you my answer. So BD equals 22.3684. So BD equals 22.3684. Let me just make sure of that. Yeah, continues on. I didn't round it, I just stopped writing the digits, ... So we have to round this as is a length to 3 significant figures. So we stop here. So it's going to be 22.4 centimeters. Okay, that's the 3SF, as is our instruction to round our non-exact answers. Okay, unless the angles one decimal place. So there we have the answer to part B. All right, now one of the dangers of what I've just done here, and you've got to be aware of that, is if you're not sure what your last answer was in the calculator, don't do this. Put the value in. Right, put the value at least up to this much, or you can recalculate and put it in. So be very careful of that. Sometimes it might not be the last answer that is in your calculator. In this case, I was sure because it was showing on the screen, and then I just typed everything else in and then put cosine answer, and it put in the correct value. Okay, but if you're not sure, you can always just go back and just put this value in to be sure. So it's going to be not this value, it's going to be 111.3987. It should still give us the same answer as this, rounded to 3SF. Okay, and that gives you 22.368, almost exactly the same thing, 22.4. So if you're not sure, just put the value in, but not the rounded value, the more accurate value. Okay, so it's 111.394, that's what we need to use, so we use that. Okay, so just be aware of that. Sometimes if the answer in your calculator isn't what you think it is, you will get the wrong answer. So just be a bit cautious about using that button if you're not sure. Right, the next part of the question says, calculate the shortest distance from D to AC. The shortest distance from D to AC. Now, the distance from D to AC is basically the shortest distance between a point and a line will always be the perpendicular distance. So from D to AC, for example, if you consider this line, that's not the shortest way to get from D to the line AC. It's still, that's not the shortest will always be when it's at right angles. That's the quickest way to get from D to AC, to the line AC. Okay, so if you're standing here and this is a wall, the quickest way to reach that wall would be to run perpendicular to the wall. Okay, so that forms for us a right angle triangle. Let's call this point X. And we have to find this length D. Let's call it D. Okay, so the shortest distance, let's call it D. Right, so we've got again a right angle triangle. So in this right angle triangle, this is the right angle, this would be the hypotenuse. This would be the hypotenuse. And this would be the opposite the angle we're trying to, or that we're given. And this would be the, well, we don't have this length, so we don't know this. So we're going to be dealing with the opposite and the hypotenuse. So TOA, we're going to use the sine ratio, opposite and hypotenuse. So we can say that the sine of the angle 62 degrees is equal to the opposite, which is D, over the hypotenuse, which is 15. So D is equal to 15 times the sine of 62 degrees. Here we didn't need to use any of the previous answers at all. You just put this straight in the calculator. 15 times the sine of 62 in degree mode, as of course we put it in the beginning, and that gives us 13.2442. 13.2442. We're dealing with a length here, so 3SF 13.2, and there's the answer to the question. So that completes question number 13, which is all about trigonometry. We have the cosine rule, we have normal SOHCAHTOA type of trigonometry, finding an angle, finding a length, and we also have this concept, which is an important concept which a lot of students don't get. And it's, you know, what do they mean by the shortest distance? Well, it's always from the point to the line that joins them at right angles. That's always the shortest distance. Okay, so that concludes the question. Other questions from this particular paper can be found in the playlist that will appear in the top right of the screen. Other questions from the topic of trigonometry in general from my collection of this new syllabus you'll find in the playlist over here. In this section, you'll find questions in trigonometry dealing with, I'm going to put sine rule and cosine rule section here. And on the top, I'll link you to the trigonometry questions from the previous syllabus. It's all the same, so you can see more, have exposure to other types of questions. Thank you for watching, and see you soon.